10.3, what about outputs? So we're talking about y values now. In an earlier activity, you saw a function representing the area of a square, function a. That's talking about number 1 on 10.2. Now we're talking about the area of a square. And another representing the revenue of a tennis camp, function r. That was question number 2. Refer to the descriptions of these functions to answer these questions. All right, 1. Here's a graph that represents function a, defined by a of s equals s squared, where s is the side length of the square in centimeters. Name 3 possible input-output pairs of this function. Really, there are infinite numbers you could put here. I'm just going to put easy ones. So if I make an x and y chart, right, x is my input, y is my output. And I'm going to put easy inputs. I could have a side length of 1, 2, 3. Right? Those are all positive numbers, so they can definitely be a possible side of a square. You can't have a negative length. And you wouldn't have a square if the length was 0, so I'm not going to start there. So if I square 1, I get 1. Square 2, I get 4. Square 3, I get 9. But I could have chosen a decimal too. I could have chosen 1.1, 1.2. Really, any of those would have been valid. Earlier, I'm looking at B now. Earlier, we described the set of all possible input values of A as any number greater than or equal to 0. How would you describe the set of all possible output values of A? So when we're talking about input values, right, we're talking about the amount a side could be. So as long as it is, well, actually, they're saying it could be equal to 0, which I don't really agree with. Because if the side length is equal to 0, then there wouldn't be a square at all. But I guess technically you could not have a square, so that would be equal to 0. But really, I mean, talking about stuff being greater than. How would you describe the set of all possible output values of A? Right, so output values of A means the area. So things I was getting in this Y column. Well, if we look at the graph, they're really talking about these Y values, right? And if you look here, every possible positive Y value is attainable. Any decimal, any fraction, it just has to be 0 or above. So it's actually going to be exactly the same as our input values. So I'm going to say any value greater than or equal to 0. And I'm only saying or equal to because the textbook is allowing 0 to be an input. You square 0, you get 0, so 0 can be an output also. But I think we can all agree that if the side length was 0, there wouldn't even be a square there, so I'm a little bit confused as to why they worded it that way. Maybe they're trying to get you to think. I don't know. Function r, number 2. Function r is defined by r of n, meaning the function r is dependent on the independent variable n, is equal to 40 times n, where n is the number of campers. Is 20 a possible output in this situation? What about 100? Explain your reasoning. All right, well, let's plug 20 in for an output and see if that makes sense. So if I plug 20 in, I'm going to write my function normally, r of n equals 40n. And I'm going to plug 20 in here. If I want to solve for n, my next step here is going to be to divide by 40. So I'm going to get 20 divided by 40, or 0.5. So they say in the problem that n is the number of campers. I cannot have half a camper. That does not make any sense, right? Cannot have half a person. It's impossible. They would not be alive if they were half a person. Anyone who's alive is considered a whole person. No matter how many limbs you have, you're still a whole person. All right, what about 100? Well, I can already tell. If every camper is going to pay $40, when I've got one camper, right, if I make a table, an X and Y table, or an N, R of N table, if I have one camper, that's going to be $40. 2 campers is going to be $80. 3 is going to be 100. I'm sorry. I psyched myself out there. 3 is going to be 120. So if I want 100 right in the middle here, that's going to be 2.5 campers. And again, cannot have half a camper. It doesn't make sense. They're half a camper. They are not attending camp. I can assure you of that. All right. 10.3. Oh, okay. All right, here we go. Here are the two graphs that relate number of students and camp revenue in dollars. Which graph could represent function R? Explain why the other could not represent the function. Well, this goes back to something we talked about way earlier in the year, first semester. And if you remember, this is called a continuous graph, and this is known as a discrete graph. So which one do we want to represent R? Well, we just talked about how we cannot have half a camper. That means we can't have any decimal values. So when you have a continuous line like that, that means that every number between 0 and 20 is being included. Every number between 0 and 700 is being included. So that's a huge issue. We can't have half a student. Another thing to look at, if we look at the constraints for problem 2, we see that we need at least 5 students and no more than 16. If we look at this graph, it starts at 5 and ends at 16. This graph has less than 5 students, so for that reason also, it could not represent the function. But I'm going to state the most obvious. Graph 2 does not have fractional inputs. And that's really what matters here. We can't have a fraction of a student. They need to be whole numbers only. All right, describe all possible output values of R. All right, so all possible output values of R, they're always going to be multiples of 40, right? Because if we look at our function is 40 times n, the number of students or number of campers. So we're always going to be 40 times 5, 40 times 6, 40 times 7. So I'm going to say only multiples of 40. Starting at 40 times 5, because 5 is our first input, and ending at 40 times 16, since 16 is our last input. So 40 times 6, 40 times 7, 40 times 8, all those would also be included. We just wouldn't go up to 40 times 17 because the camp can't have more than 16 students. All right, are you ready for more? If the camp wishes to collect at least 500 from the participants, how many students can they have? Explain how this information is shown on the graph. Okay, so I'm looking at 500, right? So I'm going to go to $500 up here on my y-axis, and I'm going to see where on the graph that hits. So I'm going across this line. And I see that it's right above, this looks like 11 students. So it looks like 11 students is not going to be enough. So we need to have either 12, 13, 14, or 15 students. Oh, I'm sorry, let me double check that. I'm sorry, that's a 12. My fault. I misread that. It was 10, 11, 12. All right, so it's got to be 13, 14, 15, or 16. How many students can they have? 13, 14, 15, or 16. Only these inputs result in an output above the line y equals 500. So remember, Y is our value, our output, the number of money we make, and we need it to be above that if we want to make at least $500. All right, that is all for 10.3.